Alright, so we're going to take a look at a really good example of figuring out what the charge is on a point charge using Gauss's law. So we have 3 point charges, Q1, Q2, and Q3, and we want to figure out what their corresponding charges are. And we have, so I've drawn Gaussian surfaces over each of them. So the blue one represents the Gaussian surface for A, the pink one represents the Gaussian surface for B, and the orange one represents the Gaussian surface for C. And each of those have denoted flux equations beneath them. Now, to really break this problem down and solve it, we need to know Gauss's law. Gauss's law is the change in the electric field. Another way to say that is the flux from a Gaussian surface. So this is a fictional surface. It's kind of a mathematical construct. We just kind of give it a certain boundary to figure out what is the change in electric field of that area. And that is going to be equal to the charge density over epsilon naught. And in this case, so charge density is equal to the charge over the volume. Now we don't actually really care about finding the charge density or using it or calculating it because we are given more algebraic representations of our charges, and because our flux equations down here simply just are stated with Q's, we can rearrange this equation just to say I care about the flux is the sum of the charges inside that Gaussian surface over epsilon naught. So that's the way we're going to formulate this equation instead of using charge density. So the way that we're going to do this is we're really going to set up a system of equations, and then we're going to solve for that system of equations. So let's look for the flux equations for the first Gaussian surface, our blue one, so our A surface. I have the flux of A as equal to negative Q over epsilon naught, and this has been given to me. And I can set that equal to the sum of the charges inside that Gaussian surface over epsilon naught. So the sum of the charges is Q1 plus Q3, and that is over epsilon naught. And I can simplify this equation, so I get negative Q equals Q1 plus Q3. And I have now I have my first equation for my system of equations. I'm going to now get my second equation, my system of equations, using the Gaussian surface of B, and that's equal to a positive 3 Q over epsilon naught, and that's equal to the sum of the charges in B, which is Q1 plus Q2 over epsilon naught. And now I get 3 Q equaling Q1 plus Q2 as my second equation, my system of equations. And let's get my third equation. So the flux of C is negative 2 Q over epsilon naught, and that is equal to Q2 plus Q3 over epsilon naught. And now I have my third equation in my system of equations. And now the rest of this is just algebra. I'm just going to use this system of equations to solve for my unknown Q's. So let's look at the first two equations. I get negative Q equaling Q1 plus Q3, and I'm going to subtract from it the second equation. So 3Q equaling Q1 plus Q2. So again, subtracting from it the second equation. So I get negative Q minus 3Q gives me negative 4Q. The Q1s cancel, and I'm left with Q3 minus Q2. And then I'm going to take the third equation, negative 2Q equaling Q2 plus Q3, and I'm actually going to add it this time. I could subtract. You could also do that too, because if you subtracted, the Q3s would cancel, but it doesn't really necessarily matter which one I do. So I'm going to add, canceling the Q2s. So if I add, I get negative 6Q equaling 2Q3. So my first charge that I've found becomes negative 3Q, and that's the charge on Q3. So now I can just directly substitute the value of Q3 in to figure out what Q2 and Q1 are respectively. Let's use the third equation again, and I can figure out what Q2 is. So I have negative 2Q equals Q2, and instead of writing plus Q3, I'm going to write minus 3Q because that's what Q3 is equal to. And I can figure out that Q2 is equal to Q. So I've gotten my second Q value. And I can do the exact same thing to figure out what Q1 is. So I can just plug it into the first equation here. So negative Q equals Q1 minus 3Q. I get Q1 is equal to 2Q. And that's how I figured out using just basic algebra and Gauss's law to figure out the individual charges on point charges within Gaussian surfaces.